So you cannot start video because it is disabled by the host.
Oh, host, why? Why are we disabled? Please switch on.
Wait a minute. You are.
Please make a
Now
video.
it is coming. It is coming.
Yeah, because there is my name also that we are running with the two videos, one for audience and another for the speaker. So
we can see
there is
the
Abhi one. So that also you need to provide the.
Avi also, okay, Avi also. We can see your hall, the lecture hall. We can see the screen, but Avi has to be enabled. Yeah, Dr. Divya, please enable Avi.
Divya, can you make Abhi as a co-host?
Yeah, now we can see. Great.
Yes, sir.
What?
Yeah.
Can you start?
Yeah, you're live streaming, right? Okay.
Good evening, ladies, gentlemen, distinguished guests, fellow scientists across the world. It is with great pride that we welcome you all to the Sama WMO Day special lecture on the occasion of the celebration of World Meteorological Day. That is being all celebrated on 23rd March. Since we are conducting this RADMAP conference, the Sama Executive Committee decided to celebrate it on this day. This year's theme, Observing Today, Protecting Tomorrow, remains us for our shared responsibility to safeguard the planet's future through science, collaboration, and innovation. Together, we honor the vision of World Meteorological Organization and reaffirm our commitment to advancing atmospheric research for generations to come. With this word, I request AVM retired Professor Dr. Ajit Tyagi, sir, President of SAMA, to propose the welcome address.
Thank you, Abhilash, and a very good evening to all our distinguished physically present colleagues and also online colleagues who are attending this WMO Day special lecture being delivered by Dr. Mahapatra, who is the DGM and third Vice President of SAMA, of WMO. Well, as brought out, the theme of this is Observations Today, Protection Tomorrow. It's a very relevant theme considering that we are living in a very, very uncertain conditions because of the climate change. And if we don't observe today, we will not be able to protect tomorrow. Now, coming to the weather as such, weather knows no political boundaries. And this was realized as early as 1873 when the directors of the meteorological services world over formed International Meteorological Organization IMO in 1873 for the exchange of data between the countries. And that initiative started bearing fruit. But during the Second World War and thereafter, there was a disturbance, and a non-governmental agency could not pursue and enforce various countries to follow the standards which were being put by them. So WMO convention was brought in place on 23rd March 1950, and that is what the WMO Day starts. Every year we celebrate WMO Day to highlight the key issues related to the global weather community and its implications for the society at large. So this year's theme is weather observations today. Now, you know that in the planet there are areas where there are data gaps. This needs to be filled, and within the countries also there are data gaps. So efforts are to be made, and towards that aim we are committed. As far as India is concerned, India has been member of the WMO right from its inception in 1950. Also, our representatives have been elected to the Executive Council, which is the governing council of the WMO, and at present our DG, who is the member of the WMO Executive Council, is also a vice president. Now, India plays a very significant role as far as the regional cooperations and support is concern providing to our neighboring countries. Our regionally specialized Med Center for Cyclone provides warnings to the 13 countries, littoral countries of Arabian Sea, Bay of Bengal, and Indian Ocean. Similarly, we conduct training for all these countries, and also we have got a South Asian Climate Outlook Forum, which provides seasonal forecast, very important for the agrarian countries of the South Asia. We also are working on third pole initiative, and also followed by flash flood program, whereas and for the urban cities, the flash flood has become a very challenging hazard, and therefore India is
You're mute, sir. You're mute. Professor Tyagi Saab is muted somehow. Just check why he's mute. Tyagi sir, you're muted. Dibya, have we muted him from outside? I don't think so.
No, sir. No, sir.
No. It is maybe something.
From their side, maybe.
Dr. Abhilash ji, could you please check?
Tyagi Saab is muted. Tyagi Saab, we can't hear.
Abdullah was agreed to, we couldn't
No, yeah.
come to Cochin to be physically present, but he will be delivering online on the theme of the WMO, and I'm sure we all will be immensely benefited by his talk. Thank you.
Yeah, next. Hello?
Yeah.
Yeah. Am I
Now it's
audible?
okay.
Yeah, okay. So we are moving towards a video message from Secretary General WMO on this occasion of World Meteorological Day. We will play a short video for 5 minutes.
Dear members, colleagues, friends, happy World Meteorological Day. There are many UN International Days. So why does this one matter? It's because today we celebrate the WMO community and its role in saving lives and serving society. Let's take a closer look. One of the most frequently asked questions is, what's the weather going to be? People take it for granted that we can find the answer on their mobile phones and televisions. Behind each forecast are millions of observations which are processed in a unique international network coordinated by the WMO. WMO Global Observing System underpins decisions worth billions, from aviation routing to flood protection, from energy planning to health management, from crop planting to infrastructure investments. It generates forecasts and early warnings that save many thousands of lives. So I am delighted that the theme of this year's World Meteorological Day is Observing Today, Protecting Tomorrow. Because when we observe today, we don't just predict the weather, we protect tomorrow, tomorrow's people, tomorrow's planet. And that is why the young people of today are so important, because they are the guardians of the future. We need your energy, your innovation, your skills. Colleagues and friends, we live in an era of great technological advances, but we must level the playing field and ensure that nobody is left behind. We must close the gaps in data and observations. And we must remember that artificial intelligence depends on human intelligence. On this World Meteorological Day, I would therefore like to pay tribute to the many thousands of humans in the WMO community. The observers in remote and lonely locations, the meteorologists who release weather balloons twice a day, every day, the hydrologists who monitor rivers at dawn, the forecasters who stay awake through the night, the oceanographers who brave the waves, the engineers who repair stations after a storm, the satellite technicians who maintain our eyes in the sky, the climatologists who help us understand the past and prepare for the future, the computer processors who crunch and share the data. We are more than just weather forecasters. Together, we provide a global public service for the global public good. Together, we are observing today and protecting tomorrow. I thank you all. And once again, I wish you a happy World Meteorological Day.
Now, let me invite Professor Dr. Someshwar Das, Secretary SAMA, to provide a brief description of activities of SAMA.
Sir, you are muted. Professor Dutt, sir, you are muted. Someshwar Dutt, sir, you are muted. Hello, sir. You are muted, sir.
Can you hear me
Hello.
now?
Now fine.
Can
Now
you, now it's okay? All right. So thank you very much. I'll quickly try to summarize the activities of SAMA. For those especially who are hearing us for the first time, I can see about 50 students and participants of the RADMAP who are sitting on the hall at Cochin, University of Science and Technology. For many of them, it will be for the first time. And also for the many members, it will be for the first time. Well, as you know, South Asian Meteorological Association is an association of 9 South Asian countries, starting from Afghanistan, Bangladesh, Bhutan, India, Maldives, Myanmar, Nepal, Pakistan, and Sri Lanka. We were established about 5 years ago on 3rd of August 2020. Just now you heard about the Secretary General's message for the WMO Day, and the Secretary General has specifically also appreciated SAMA. She wrote us the letter saying that she appreciates the efforts in capacity building and training by SAMA. This commendation recognizes SAMA's impactful work across 60 plus countries in South Asia and among non-aligned movement member countries. Professor Saulo particularly emphasizes the exceptional collaborative initiative undertaken by SAMA, which have significantly contributed to the advancement of meteorological understanding and practices in this region. Well, the vision and mission of SAMA are sharing knowledge of weather and climate without borders and meteorology for the sustainable development of the region. It is a non-profit international scientific society, as you know, and we have got a website which is displayed here. Well, as on today, SAMA have got about 825 members, including 496 life members and about 329 student members, and the distribution of members per countries is displayed here. I'm not going to read this. Well, the core objectives of SAMA are professional interaction, that is foster collaboration amongst meteorology professionals across South Asia, scientific advancement, that is to drive progress in meteorological and allied sciences throughout the region. Our public outreach is to communicate climate change knowledge through citizen science programs. For the sustainable development, apply meteorological sciences for the regional sustainability and resilience. And for partnership buildings, we promote public-private academia partnership for social applications. Well, we have many knowledge partners, about 17 of them, including EC Mode of Nepal, established in Nepal, RIMES in Thailand, NAM Center, there is an Land Movement Center of Science and Technology, which has got about 47 member countries. Shaseni, SAFOM is sister organization of SAMA, which is specialized for the agriculture meteorology. Charlotte is the South Asia Lightning Network. Sahil is for the South Asia Heat and Health Information Network. SRM IST University in Chennai. SIDAC is the Center for Development of Advanced Computing in Pune. BIT Mesra. There is the Birla Institute of Technology. ACARR, CUSAT. We have been conducting this program on RADMAP for the last 4 days at ACARR. And the Department of Meteorology, Dhaka University's Central Department of Hydrology and Meteorology at Road University, Kathmandu, Nepal. Pune University, Noami, Bangladesh. FERCC is the Federation of Education and Research in Climate Change, Foundation of Education and Research in Climate Change, and HOESA. These are our knowledge partners, and many more are still joining us one by one. SAMA has got many scientific committees, including education and research, numerical weather prediction, satellite meteorology, radar meteorology, air pollution, climate change, and mountain meteorology. Well, the major activities conducted by SAMA since 3rd of August, its establishment on 2020, are about 130. And all of them were conducted at zero budget. As I mentioned earlier, this is for the first time that we have conducted the physical activity, which is a training workshop and conference on radar meteorology at Cochin University of Science and Technology at Kerala. SAMA conducts webinars, training workshops. It conducts capacity building programs, lecture series. We have conducted 5 lecture series in the last 3-4 years, starting on atmospheric physics, which was conducted for 4 months, in which about 2,000 people registered from 48 countries, especially those were from the NAM member countries, besides our own 9 member countries of South Asia. Then we conducted the WRF modeling system training in collaboration with SIDAC. Then we conducted a lecture series on satellite meteorology for 5 months. After that, we conducted the lecture series on radar meteorology for about 6 months, in which 1,200 participants were there, registered from about 48 countries. Then we conducted a lecture series on atmospheric dynamics, which was, of course, over last year. Then we also celebrated the special day, like today we are celebrating the WMO Day, Ozone Day, etc. We conducted quiz contest for the school children, in which many thousand students participated from all the 9 South Asian countries. We conduct special lectures on works of the Nobel laureates, those especially who were given the Nobel Prize in the atmospheric science 2 years ago, Professor Manabe and Professor Hasselman. Then recently, we just concluded the workshop on radar meteorology, RADMAP, and the conference has just been inaugurated today. We are conducting another program called WISE, which is a program for the school children to educate them on weather, climate, and environment in the school education. We have launched also a program called In Clouds, which is the cloud-based research over the Himalayas, particularly with India and Nepal, which are affected most by the cloudburst every year. Then there is another program called Yours, that is the Young Researchers Colloquium, and that is meant for especially the young researchers in these South Asian countries who are working with less privileged facilities, and who don't get the chances to interact with the experts in the field internationally. So we launched this program called Yours, Young Researchers Colloquium, in which the young researchers, especially the PhD students, also the MSc final year students who present their thesis, they can interact with the experts and then get ideas from international people, from international experts. Then, of course, this just maps demonstrates the number of countries who attended or who at least registered for our lecture series that we conducted, the 5 lecture series in the last 2 years on different subjects. And we also have this program called Sama Student Championship Award to encourage the student members of Sama. Every year we provide or we give a Sama Student Championship Award for those students who contribute in conducting the activities of Sama. So they're selected and then given the award on the Foundation Day of Sama, that is on 3rd of August every year. And some of you already know that Sama, in association with India Meteorological Department, IMD, Indian Meteorological Society, IMS, we conducted the first meteorological Olympiad last year to commemorate the 150 years of establishment of IMD. And that was a historical achievement in which about 24,000 students registered, about 12,000 participated, about 322 winners were invited from different states to Delhi. And out of them, 289 attended the final exam. And from that exam, the top 3 winners at national and state levels were awarded prizes. The prizes were like 25,000, 15,000, and 10,000 with mementos and certificates at national levels. And similarly, for the state level winners, we provided certificates and mementos plus cash award to the state level winners also. We prepared study materials for the school children before they attempted the examination for the Olympiad. And this award was acknowledged. In fact, in the final ceremony, the Prime Minister of India, Sri Narendra Modi ji, physically attended the program and blessed the children, encouraged them, all the winners of the state and national levels. So this is the historical program that we started in association with IMD, IMS, and BIVA, that is Began Bharati. And as already mentioned, we have launched 4 new programs called YARS, that is Young Researchers Colloquium, already mentioned about that. Then RADMAP 2026 just concluded, the workshop part concluded today, and conference has been inaugurated, which will start tomorrow. Then the next is WISE Sama, which I already mentioned, is about weather, environment, and climate in school education, WISE, which is dedicated program for the schools teachers, especially for science and geography teachers of a school, just to fill up the knowledge gap in their syllabus about the weather and climate. And as I mentioned, we have also launched a program on cloudburst over the Himalayas. So these are the 4 new programs which Sama has launched in the last 1 year. Sama also publishes 6 monthly newsletter. And we are present in different medias to contact us. We have got the website, we have got the Twitter handle, we have got the Facebook account. We are also present on the YouTube channel. Today's program is being live streamed on the YouTube. Also, all the videos of the webinars organized by Sama, as well as all the lecture series that we have conducted in the last 2 years on the 5 important subjects, are all available on the YouTube channel of Sama. We have got a WhatsApp group and Google group members for all the members of Sama. And we are also having a LinkedIn account. So thank you so much for listening to us. Thank you very much. On to you, Dr. Avilash. I will now
Thank you, sir.
stop
Being
sharing the
kind
screen. Yeah.
and describing the activities of Sama, outreach activities of Sama. So next, I invite Ms. Chadushka Premachandra, Senior Meteorologist, Sri Lanka Meteorological Department, and our ECT member of Sama, to introduce the chief guest to the audience. Thank you. Ms. Chadushka Premachandra.
Yes, I'm here. Okay, wait
Yeah.
a minute.
Full screen. Slides. Yeah.
Good afternoon, everyone. It is my great honor and privilege to introduce our distinguished chief guest for WMO Day 2026, Dr. M. Mohapatra, a globally respected scientist and an inspiring leader in the field of meteorology. Dr. Mohapatra currently serves as the Director General of Meteorology at India Meteorological Department and is also permanent representative of India to the World Meteorological Organization, where he holds the prestigious position of third vice president. His remarkable journey reflects decades of dedication, innovation, and service in both science and society. Born in 12th of August 1965, Dr. Mohapatra pursued his higher education in physics, earning both BSc, Master and PhD, laying a strong academic foundation for his illustrious career. He began his professional journey in 1988 and joined IMD in 1992. Over the years, he has held numerous key positions, steadily rising through ranks from a meteorologist to director, scientist, and ultimately to the head of IMD. His career spans critical areas such as weather forecasting, cyclone warning, disaster management, and numerical weather prediction, contributing immensely to the safeguarding lives and property. Dr. Mohapatra is widely recognized as a pioneer in cyclone forecasting and early warning systems and called as the Cyclone Man. His work has significantly improved the accuracy and timeliness of forecasts, especially in the North Indian Ocean. These advancements have played a crucial role in minimizing the loss of the life during severe weather events. In addition to his operational excellence, Dr. Mohapatra is a prolific researcher with over 160 scientific publications, numerous books, and extensive contribution to the national and international conferences. His research covers key areas such as cyclone, monsoon systems, heavy rainfalls, and thunderstorms. His contributions have earned him numerous prestigious awards and recognition at both national and international levels. Notably, he has received the United Nations Sasakawa Award for Disaster Risk Reduction in 2025 and the Outstanding Service Award from the American Meteorological Society. These honors reflect his global impact and leadership in disaster risk reduction. Ladies and gentlemen, Mr. Mohapatra's life and work stand as a shining example of how science, when combined with education and vision, can serve humanity in the most meaningful way. Today, we are truly fortunate to have such an eminent personality among us. His presence adds great value and inspiration to this event. On behalf of everyone present here, I extend a very warm welcome to our chief guest, Dr. Mohapatra, and invite him to address the gathering. Thank you.
Over to you, sir. Mohapatra, sir.
Sir, you are muted.
Yeah.
Thank you, sir.
I think you can stop sharing so that I can
Yeah.
the PPT. Yeah.
Mohan, Dr. Mohan, you have to share.
Yeah.
Yeah.
Yeah. So good evening, namaskar to all of you. Respected Professor Ajit Tyagi, former Director General of Meteorology, India Meteorological Department and President of SAMA, Professor Someshwar Das, distinguished members of SAMA, distinguished delegates, ladies and gentlemen. At the outset, I extend my heartiest congratulations to SAMA for organizing this celebration for World Meteorological Day and giving an opportunity to interact with all the giants participating in this program and also the students, the researchers present here. I have been associated with SAMA for a long time, and I find that there has been a huge service delivered by SAMA, especially bringing together the various stakeholders in terms of the researchers, professionals, students in the South Asian region. It has also enabled the capacity building of the region by exchanging the knowledge, experience, and expertise. It has also brought out various training programs, short-term training programs, which is also helping in the improving the capacity, and also students are now enjoying to take it as a hobby, to understand it and practice it, and hence to minimize the adverse impacts of weather and climate in this region. The SAMA played a very important role considering the physiographical variation in this region and the vulnerability of the region. As you understand that we have the Himalayas to the north and Bay of Bengal, Arabian Sea to the east and west, Indian Ocean to the south. We have got the great deserts in the region. We've got many hill ranges, and also there is large variation in the demography. And if you look at the various type of activities carried out in this region, also socio-economically, the region is very diverse and also poor compared to many other regions in the Western world or other parts of the world. So due to all these limitations, it is the knowledge which can empower us, which can save us from the adverse impact of disasters. All of a sudden, the region cannot change the infrastructure, cannot change the infrastructure required for the early warning, cannot stop the ill impact of the climate change, where this region may or may not be responsible for that. But they become the vulnerable day in and day out. So therefore, I feel in such a scenario, the role played by SAMA towards the knowledge increment is very fruitful, and in the days to come also it will be very fruitful. So therefore, I express as a person deep gratitude to all the leaders who have led the SAMA and also those who are associated with SAMA. Well, coming to the topic, yes, I extend my warm greetings on the occasion of World Meteorological Day. As all of us know that last year, WMO completed 75 years. And if you consider 1873 as IMO, then it completed 152 years. And IMD has been, therefore, the contemporary with WMO. And since independence, we have been, or you can say since the genesis of the WMO, IMD has been associated as member, and also consecutively the Executive Council member. And there have been 3 vice presidents, including me. And many experts from the region has been associated. Even this region has been RA2 presidents or vice presidents sometimes. So therefore, the region of South Asia has played a dominant role in the international policy, planning, coordination, implementation of projects, and the programs. So as a result, it is not that South Asia has been benefited by the world, but also South Asia has contributed immensely towards the world. And needless to mention that this region people also has been receiving the accolades and recognitions, including the IMO prize. So that itself suggests that the human expertise in this region is also too rich to contribute towards the international development. Now, the future, if we just look at it, is the climate change, which is being discussed day in and day out, and that has prompted more sharp approach by each individual and each organizations. And towards this direction, this year, the theme that is the observation is the first and foremost priority. We all understand long back that weather forecasting is an initial value problem. If you have the good observations, quality observations, frequent observations, dense observations, then it can help you to better detect the various types of weather events, and also you can provide the forecast. So with this theme, observing today and protecting tomorrow is very much apt on today's world when you consider the various socioeconomic development, threat due to climate change, vulnerability of different populations, and need for democratic approach in providing weather and climate information to each and every person in terms of disaster risk reduction requirement or Sendai framework requirement or the early warning for all initiative taken up by the WMO and United Nations. At the same time, we are also going through ocean decade. So that is IOC, and there is a good collaboration. So considering all these, therefore, each and every country is also gearing up to improve the observations and improve the forecast, improve the outreach, so that each and every person, irrespective of the caste, creed, religion, gender, is empowered with weather and climate informations. So towards this direction, India Meteorological Department in the Ministry of Earth Sciences has been given a responsibility that is called Mission Mousam. And today I will be discussing something about the Mission Mousam. Even though it is a mission taken up by India, but the outcome of the mission is applicable or you will be utilized by the entire South Asia and beyond. So let us look at what is the status today. If I look at the world, the Weather and Climate Service now operates in 190 plus countries and coordinated under the World Meteorological Organization. The observations from thousands of stations worldwide form the backbone of weather forecasting. So India served by IMD since 1875. At that time, of course, it is undivided India, and we all work together. Now, if you look at the observational network, there is about 60,000 plus weather stations worldwide. The observations increased by about 65% during the recent years, that is 2019 to 2024. The data are shared from this observational network by 140 plus countries. If you consider IMD, then we've got 547 surface observations, 1,008 automated stations, 1,382 automated rain gauges, 48 radar, now it is 48 radar, 56 radio sound stations, and 6,727 rainfall stations being utilized to generate the rainfall information at district and block level. So if you look at the threat of climate change, which I was talking about, all of us know that the global mean surface temperature is increasing. It is shown here from 1850 to 2025. And there is a sharp increase since 1970s, you can say. And whatever target was fixed in the initial period that we will be reaching 1.5 degree by 2100, now we are thinking that during next 1 decade or 2 decades, perhaps we will get 1.5 degrees Celsius. So therefore, every time the projection changes and our system modeling also empowers us to take a judicious decision with respect to adaptation and mitigation. And really it becomes challenging when your target is changing more frequently because of this changing behavior of the climate. So whatever it may be, so you can see that it has been 1.43 degrees Celsius in 2025 global temperature rise, where we are planning for 1.5 degrees Celsius. You already are reaching out 1.43. Not to mention that 2024 was the warmest year. Then CO2, if you just look at it, is 420 parts per million volume. It is a record high. And sea level rise about 4.7 millimeter per year. The ocean has been absorbing, of course, 18 times the annual human energy use each year for the past 2 decades. So much of energy is being absorbed by the ocean. If you just think of, and sea surface temperature is increasing. At the same time, it is become the carbon sink, but it's certainly limit to absorb the carbon dioxide. So therefore, it is affecting the ecosystem. It is affecting the aquaculture. It is affecting the entire food chain, which is linked with the ocean. The temperature rise is about 0.7 degrees Celsius since 1901 in India, and the extreme rainfall events increased by about 20%, and heat wave is increasing frequency and intensity apart from others. So if you look at the extreme weather events, 150 plus major disasters occurred worldwide in 2024, taking an example, and 800,000 plus were displaced globally. So 41 extra heat wave days were realized due to climate change. Floods, heat waves are increasing, as all of us know. Heat wave alerts issued for most of the districts, and monsoon variability is impacting the agriculture. That we have seen and the impact earlier because of El Nino only. But now the variability is more. You can see the spatial changes, like the eastern part getting less rain, western part getting more rain, and those temporal changes like the frequency of heavy rainfall becoming more and light and moderate rainfall becoming less. So therefore, coming to the disaster risk reduction, you will find that globally we have been geared up. We have been working together. We have been facing the challenges, but we have been able to minimize the loss of lives. So loss of life has been reduced by 30 to 40% globally, and about 50% countries fully covered by the early warning system. So if you think about when early warning for all call was given, more than 50% or roughly 50% of countries did not have the early warning system. Still, we have been able globally to minimize 30 to 40%. So if you can ensure early warning system for each and every country, if you can ensure early warning for each and every person, each and every stakeholder or the organizations, you can just imagine how much you can save from the disasters. The cyclone track accuracy, all of us know that it has been a paradigm shift in the services for the region, and the entire region has benefited. If we just look at early warning has helped the disaster managers in the entire region to minimize loss of lives and properties. Warning is being provided 3 to 5 days in advance, and fatality is reduced. And recent cyclone, you know, it was nil in Cyclone Dana and Cyclone Viparjay in 23 and 24. And it is only single digits or double digit maximum in any country in this part of the globe. So therefore, that negative impression, that's the adverse impression, talking about say 1990s or 1970s, Ebola cyclone onwards, that has been erased. So that is the most important achievement of the South Asia, that we have been able to minimize the loss of lives. Now, let us look at technology and collaboration and globally coordination by the World Meteorological Organizations. Global data sharing improves the forecast that everybody knows. Many modelers are there in this meeting. So many papers are published based on data assimilation, initial and boundary conditions. All these are dependent upon the global data. So high resolution models, if you just look at is in place 1 kilometer to 12 kilometer, then forecast updates, you will say that it is updating 4 to 8 times. I would say why 8 times? High resolution rapid refresh model is being run over the region now, which is providing forecast every hour, and it is updated every hour with the simulation of the radar data. On the way to use emerging technologies, AI/ML, all of you very happy that NCMRWF has included 3 AI models now, and we have got 7 models running physically. So we have got 10 models available at present. So what to do then? So sometimes more information also confuses the forecasters. So therefore, there is a need to streamline and complement each other. So complementarity between physical model and AI model is the future where we are working towards their directions. Now, if you just look at public services, early warning initiative, early warning for all, it has taken off in 2022 with a 5-year period, 2027. Forecasts reach millions daily through mobile apps, social media, print media, TV, SMS, etc. Can you imagine? We are reaching out to the farmers directly, just like direct benefit transfer. The IMD's forecast is being transferred to the each individual farmer, and we have kept the target that 5 villagers in each village should get the information, and we have reached out around 2 crore farmers by that way. Then agromet services for all districts, as I told you, the aviation support, you see 107 airports are getting forecast now. Marine services, 4 million fishermen get the information every day. Every data set contributes to saving lives. The observations today enable early warnings, preparedness, and resilience. I want to mention here, considering this impact of climate change, now fishermen warning is being provided for the entire North Indian Ocean, helping the South Asian countries to minimize the loss of lives and properties and optimize the operations for fishing, etc. So it is a very oft, therefore, what I told you, observing today and protecting tomorrow. And IMD is sharing this global responsibility. Now let us look at a specific sectoral application. For example, aviation meteorological services. We just look at you will find that there has been huge intervention with the technology. Each and every airport has the digital current weather instrument services. I should thank Tyagi here. Actually, he has taken a huge initiative towards this augmentation of various kind of services initially, and I was associated with him in 2007 and 8 when the first modernization program was taken up, and that is continuing. And at present, we have gone up to 137 6 digital current weather systems from 56 in 2021. So therefore, I have to say that in the recent 5 years, there has been significant improvement also in the technology intervention for specific applications. So this is another important application which is helping the South Asia and the region, that is the hydromet services. I want to say that the flash flood guidance system, South Asia flash flood guidance system is being operated from Delhi and is being provided for 4 lakh watersheds, 1 lakh watersheds, and each watershed has the size of 4 into 4 kilometers. That means almost smallest watersheds are getting the information provided every 6 hours, and it provides the flash flood threat valid for next 6 hours, and so flash flood risk. And it has been developed with the help of the WMO and US Hydrological Research Center. It provides and includes all the information, including satellite data, radar data, AWS data, and daily rainfall monitoring data, and also the soil moisture data from different sources, and along with the models, and evaluates the potential for development of the floods in each river catchment. In addition to that, there has been improvement in quantitative precipitation forecast for the different river catchments. Now we are providing forecast for 160 river catchments in the country. And there also another intervention is in there at the same time. We do not give the deterministic forecast of the quantitative precipitation forecast, also give the QPF in a probabilistic manner. Probabilistic, if we say that the amount of rainfall will be in the order of 26 to 50 millimeter over a certain catchment, say for example Cochin, we say what is the probability. So accordingly, the color coding is also there to take care of the impact-based informations, and at the same time we ensure also early warning to early action. Just like in case of cyclone, it is well-defined early actions based on early warning of IMD. Similarly, in other sectors also. For example, let us take the hydromet sector. When we give the warning for the heavy rainfall or the flash floods or higher amount of quantitative precipitation forecast, Central Commission, IMD, and the National Disaster Response Force, they meet every day, either over phone or through VC or physically, to decide where to deploy the National Disaster Response Force, what action is to be taken by the state government, what action is taken by the disaster management authorities, dam authorities, irrigation authorities, like that. Now, this is another development which has taken place recently. India Meteorological Department introduced district-wise rainfall monitoring scheme in 1992. Because of the limited number of the observatories, it was not taken up for large number. But in 2025, we moved towards the block-wise rainfall monitoring scheme. That means 7,000 blocks have the statistics of rainfall since 2025. And finally, our target is to go towards panchayat level. Now, another initiative what has been done in recent times is the Panchayat Mausam Seva. So this Panchayat Mausam Seva is a collaborative approach with the Minister of Panchayat Raj, just like the water services with the Minister of Water Resources. In this, Minister of Panchayat Raj and IMD work together to provide the weather forecast communication through the Panchayat Secretary, Ward Member, and the Sarpanch of the Panchayat. Similarly, we have got the Krishi Sakhi and Pasu Sakhi to Minister of Rural Development, where the women empowerment is being ensured for Krishi means agriculture, Pasu means animal husbandry, and they are the women, and through them information is being provided at every panchayat. Now, we have come up with the dynamic crop weather calendar. Earlier it was static crop weather calendar for 130 agroclimatic zones, but now district-wise dynamic crop weather calendar has been prepared based on the revised onset date, withdrawal date, crop technology, climate requirements, and potential impacts. When I say dynamic, that means it is sensitive towards the current situation. That means if this year onset becomes delayed, onset becomes early, according to what action is taken by the farmer, that is can be found out from this dynamic crop weather calendar. So this is another new initiative which has started actually in Commonwealth Games time during Tagisab as DG. We started the first nowcasting for non-aviation purpose. Of course, aviation nowcasting has been a long take, starting with the initiation of the aviation weather forecasting. But non-aviation forecast started with Commonwealth Games in 2010. But now we have come up to the stage that on the left-hand side, you can see we can draw a polygon where we are expecting the severe weather during the next 3 hours. And accordingly, information is generated on the right-hand side, and it goes to various users. This is another thing I want to say, that for the long time we are issuing, I think the first long-range forecast started in 1878, if you remember, by Henry Blandford, and that forecast was for all India as a whole, and that was based on the Himalayan snow cover vis-a-vis the rainfall expected. So it was a good relationship, and that relationship is also being utilized at present. That was only based on the one parameter, and gradually it increased, and we came up with the Walker's solution, that is El Nino, which we call now the ENSO. And gradually also we came up with various parametric model, that is statistical models. Then finally 16 parameter model, then 8 parameter model, then different homogeneous regions, India as a whole. But we never attempted for the entire country. In 2021, we took the initiative to provide the monsoon rainfall forecast for the entire country. You can see on the right-hand side map, the forecast issued in April and forecast issued in the end of May. So, for example, this is the forecast for 2025. You can see that forecast was telling that most part of the country will have the above normal rainfall, that's the blue color, or normal rainfall, and yellow color is the deficient rainfall or below normal rainfall. It has come up very nicely if you see the actual rainfall on the left-hand side diagram. So what I have to say that it was a very ambitious initiative, and it was taken. I should thank my climate group in Pune. Because of that, we could come up with a dynamic statistical modeling system utilizing statistics, utilizing about 10 global coupled models. Out of that, 5 best models are selected every year based on the performance, based on the hindcast, and forecast is generated for the ensuing monsoon season. I want to say that this forecast has become very correct. If I compare 21 to 25, we've come up 5 years now. Our average error in long-range forecast is about 2.3%. That means all of you remember that long-range forecast is provided like rainfall is likely to be 105% plus minus 4%. So the error is here is 2.3%. That means it is well within the error limit. That forecast is absolutely correct. But if I compare the previous years, previous 5 years, our error was 7%. That means not only this forecast is now catering to the requirement of the different parts of the country, but also the overall accuracy has improved. And if you look at spatial accuracy, it is about more than 80% of area correspond to the same category of forecast. Now, if you look at the extended range forecast, which has also started in 2012, experimentally we started, and now we are providing extended forecast based on 3 extended range models. We are running one extended range forecast model in IITM1, another in NCMRWF, and based on 3 extended range forecast, we are issuing the forecast. It is capturing the hot spell, cold spells, and wet spell and dry spells. You can see that on the right-hand side, there is a comparison of the forecast accuracy. So there is a significant improvement in 21-25 compared to 2016-20, but this is limited only to week 1, week 2, and week 3. Beyond week 3, there is no forecast accuracy, and hence there is a gap. Now let us look at what for we are issuing external forecast. Yes, we are issuing for purpose. We are giving the long term during the next 4 weeks what is going to happen. But however, we have gone one step further to find out about disaster risk reduction. Based on external forecast, we started providing in 2025 the probability of occurrence of heavy rainfall, probability of occurrence of very heavy rainfall, or probability of occurrence of extreme heavy rainfall. In a similar manner, this year we are starting the probability of occurrence of heat wave and cold wave based on this extended forecast. This is an example of the implemented AAML model. In one model has come up, the 3 models have been implemented it is just the customization, I will tell you. It is not the development of the model in NCMRWF. Similar customization has been done in IMD1 model. So now AAML model are coming up. There are groups working in AAML, and there is scope also to improve the forecast with the help of the AAML. So once you have got all these informations based on observations or the modeling, that is not the end of the day. Finally, the forecaster, like a medicine specialist, based on all the prescriptions, based on hospital prescribed tests, he will come to a conclusion, a medicine specialist, what is the disease and what is the forecast. That means what is the medicine he will give. Similarly here, a forecaster has to take a decision, irrespective of 10 models, irrespective of thousands of data. He has to say actually what is the fact, and he has to say also what is going to happen for next 10 days or next 7 days, etc. So that decision making, it was completely manual. And we came up with some kind of decision making with help of the first Meteorological International System in 2009 in the first modernization program, but that was limited to only 10 to 12 offices, where we have got 200 forecasting offices in the country. So considering all these things, we came up with indigenous development of the multi-hazard early warning decision support system. And this is the sketch of that multi-hazard early warning decision system. It is completely indigenous, it is completely scalable, it is completely replicable, and it can help in other countries provided the data sets are available. Now, this is the architecture. This is the open source technology, and it has got two decision support systems. One is for the forecaster, that is a back-end decision support system. Another one is the front-end decision support system, which is used by the general public. I request all of you, please visit IMD website or Motion Mobile app. You can go to, for example, heat wave page. You can find out what is the temperature in your area in GIS map. You can find out what is the temperature for past 7 days, whether there was any heat wave conditions, how many days heat wave is there, and also you can find out similar conditions in the next 7 days. Not only that, you can also find out what is the impact expected and what is the action suggested. All these informations are available in public website in the web GIS, and that is helping. I will tell you, the number of visitors has increased from 7 crore to 12 crore after the implementation of this multi-hazard early warning decision support system. This is the geospatial service I was talking about. There are various pages. This page you can find out in our website, and all types of information are available for various stakeholders. I am just showing one example here. And this is the tropical cyclone Dana, which crossed Odisha coast in 2024, and the result was 0 deaths. So what was happening earlier, actually, we have been very good performer in cyclone warning, and our accuracy has helped the disaster managers to minimize loss of lives. But still, there are certain gaps, like different agencies. For example, Central Water Commission will issue the flood warning. We will be giving the heavy rainfall warning. District warning will be given by our state met offices. Severe weather warning is given by the South Asia Severe Weather Forecast Program, and there is storm surge is given by. So all these informations were scattered. Now in the DSS, we have integrated all the supporting systems, and by that way, we have integrated information. A public can go to IMD's website cyclone page, and they can find out by clicking storm surge overlapping with the cyclone track, and hence they can assess which area, whether his village or her village is going to be affected by the storm surge. So this is called a multi-hazard interoperability that is ensured through this modernization of the DSN support system. Now, next one is the heat wave, for example. I'm just putting up here. You have got heat wave, severe heat wave. At the same time, study says that heat wave is not so much important if there is no warm night. If it is a warm night, the death becomes higher, because all of us know that warm night, poor people cannot sleep. Even in city area also, there will be tripping, and there will be no power. And there are very few people who have the additional supporting system. So therefore, warm night information is also being generated and provided in the forecast. So severe warm night persistence. If heat wave is occurring for 1 or 2 days, it doesn't matter. If it is persistently occurring over a region, it becomes disastrous. Then we provide information about the persistence of heat wave and severe heat wave, persistence of warm night and severe warm night. Similarly, now to find out the extreme condition of the temperature, we provide the percentile. So 95th percentile, 98th percentile of the information provides how extreme is this heat wave conditions. Then, of course, humidity is taken into consideration, and temperature humidity index, heat index is generated. That is also provided to the public. So finally, what we do actually, we consider all these informations, prepare a composite heat index, and that information goes in terms of color-coded map to the general public. But however, all these information are also available individually. You can click on the website and see one by one. Now, not only that, once you give all this information, so you give that red color, orange color somewhere in the particular district, for example, Jodhpur I am showing here. In the Jodhpur district, if I am telling that there will be heat wave or severe heat wave condition, I have given the orange color warning. then I should tell what is the impact expected on human health, agriculture, livestock, transport, economy, or resources, and what is the action to be taken for human health, energy, livestock, etc. So this information is being provided. In addition to that, all the infrastructure like national highways, Indian railways, Indian railways is one of the worst sufferers in the heat wave conditions. Because they have to make arrangement for water, they have to ensure safety for the coolies and other people working in the platform. They have to ensure AC working well, otherwise all of us will curse Indian railways without understanding that there is a heat wave conditions. So therefore, all actions are required once you give the information. Therefore, directly information is going to the individual users. This is another one I want to introduce. You can find out the Mosam-gram. Mosam-gram, as the name suggests, it is the weather at village level. Mosam-gram. Gram means village. So we started the slogan that is Harar Mosam, Harghar Mosam. Its English is that early warning everywhere at any time, anywhere at any time. Information should be available anywhere at any time. So therefore, if somebody has gone outside in a ship or in a boat and he is able to access our mobile app or our Mosam website, they can find out information over the ocean itself. If somebody is going for an expedition in the Himalayas, they can also get our information. If somebody is going in a desert, they can find anywhere, not only India, but other countries also in the season, they can find out the information at the location by giving the latitude, longitude, or by giving the name of the panchayat, block, tahsil, district, etc., or by giving the postal index number, PIN code. So this is what you can find out. This is a 10 days forecast. It provides hourly forecast up to 36 hours, 3 hourly forecast up to 5 days, and 6 hourly forecast up to 10 days. Then comes another example. I have shown you thunderstorm warning. This is another important initiative has been taken up. That is called as nowcasting common alert protocol. So what we do actually nowadays, there is no point that I should give warning for X or warning for Y. It is the polygon. You can see in the state of UP, we have drawn the polygon here. I have just expanded here warning area with different color code like yellow, orange, and red. Wherever it is the orange and red color, once you get this warning, immediately the State Emergency Operations Center pushes the SMS and it goes to general public. Except for other primary mobile app, etc. This is the forecast given for valid for next 3 hours. And you can see how the forecast accuracy improved for thunderstorm from 0.57 POD to 0.87 POD in the last 5 years. Now, this is the probability detection of the heavy rainfall. You can see how significantly it is improved in recent time. And at present, it is the 85%. POD is 85% compared to 77% in 2020 in detecting 1 day ahead heavy rainfall in a meteorological subdivision. So I want to say that there has been almost continuous improvement, but accelerated improvement in the recent time because of all these initiatives. Now, this is the major achievement in the weather services with respect to thunderstorm. I have told you earlier, it's a repetition only. But the nowcast also has improved. It provided detection of thunderstorm in nowcasting is 0.92 in 2025 against 0.67 in 2013. We started at that time. Now, if you look at the forecast skill for heat wave, you can find out that yes, it is a very good skill. It is more than 80% if you consider day 2 forecast at least. Now, this is the forecast from cyclone. All of us know that there is a continuous improvement, and accordingly, we have come up with a scale where we can compete with, and it's better than many leading centers. Even it's far better than JMA, and at par with the USA. Now, with all these success stories, I want to say the challenges, and if you look at the challenges, it is the climate uncertainty. The climate uncertainty has increased globally because of this climate change. Unequal observation infrastructure. There are countries where you will get observation every 50 kilometers. There are countries you will not get any observation in every 200 kilometers. So density varies largely. The large geography of India and data gaps, especially in Himalayas, oceans are the origin. The extreme weather events are increasing under the impact of the climate change. So if we go a little more the gap areas, long range forecast, still there are certain gap areas to improve the forecast accuracy. So our modelers in IITM says that we can go up to 0.85 the forecast accuracy, that is CC 0.85. But still, therefore, we have the hope that we can improve further the long range forecast. Similarly, extended range forecast, I told you, even though we are issuing forecast up to 4 weeks, it is good up to 2 to 3 weeks only. But internationally, people are issuing up to 6 weeks. The European Center predictability is low, though there is scope to improve, mainly due to lack of observations, limited computing systems, and modeling with respect to interim forecast. Impact-based forecast, yes, we started impact-based forecast, and from 2019, distributed impact-based forecast and location-specific impact-based forecast being provided, but still there is a long way to go because impact-based forecast cannot be provided by IMD alone. You need the socioeconomic parameters, you need the infrastructural parameters, geospatial parameters at high resolutions. So therefore, we have to continuously proceed in this direction to further minimize loss of property. So loss of life is minimized, it can be further minimized, but loss of property will be minimized only with impact-based forecast and risk-based one. Then comes the cyclone forecast. I told you the intensity forecast still is challenging and difficult tracks. Like for example, this year, if you just look at cyclone Mantha in an example, if you look at the cyclone which developed Malaysia and Indonesia, if you look at the cyclone which developed south of Sri Lanka, all the cyclones in 2025 has been challenging because of their typical track. So there are difficult tracks, there are intensity problems, especially rapid intensity problems, which are still to be addressed. Then if you look at the climate change threat to the predictable severe weather, yeah, it is a known fact that because of the climate change, the predictability decreases. But however, predictability can be sustained and further increased only with increase in observational network, quality observations, dense observations. If you look at the observational technique with the world improving with the technology, so aircraft, UAV reconnaissance, etc., still a dream. We are not able to do that. And then ground-based mobile systems and then IoT-based observations, all these things also are the futures. The gap in modeling systems, just look at, we have limited probabilistic information about the severe weather, like heavy rainfall, wind, and storm surges, etc. So that can improve further. And AML tools, regional modeling. For example, during the last cloudburst event which occurred in the Himalayan region, there was demand that can we run the models in the state level, say Himachal Pradesh alone with high resolutions. Yes, model can be run with a high resolution, but you have to ensure that there are data. If you do not have data, simply running the model is not sufficient. But at the same time, there is a demand from the stakeholders. So in the power sector, they need information forecast of every 15 minutes, where model may not be possible to provide every minute 15 minutes forecast with reasonable accuracy. So there comes the role of AML to provide the information which is not being possible with the physical models. The AML can help in downscaling the physical model output. AML can help in improving the forecast accuracy. AML can help in fulfilling the requirement of the stakeholders, like the fishery sector or the power sector, or the health sector, or the hydro sector, any socioeconomic sectors. Now way forward. So way forward are many, but Mission MOSAM was one of the most important way forward was considered by the government. And in the way forward, the most important thing was expanding the observational network. Actually, whatever the theme this year that was well thought of by even the political leaders in the country, and they could visualize the impact, and hence they decided to go for Mission MOSAM with most important emphasis on the expanding observational network. And then, of course, on the way to improve the forecast accuracy by 10 to 20%, increasing the radar coverage by 100 plus Doppler radars, and strengthening last mile early warning systems. So if I just talk of Mission 26 to 31, then challenges remain in accuracy and reliability, complexity of weather systems, limited data availability, but implementation of Mission MOSAM will require strengthening of observations, gaining better understanding. There is the role of academia, research, and development institutions. Then innovation, methodology also will play a key role. Then improve our model and simulation and augment the HPC. Recently, we have augmented our HPC, but still that is not the end of the road. We have to improve further the HPC. Then forecast dissemination. As I told you, no one should be left behind, as Secretary General told. So every person in the globe should get the information on early warning. So your initiative, therefore, will help towards the direction, which is the public-private participation. So observational systems, we look at we made an analysis before going for mission Mausam. So where you should have Doppler radar. We thought that we should have Doppler radar for entire country to be covered up, and all cities where you have a population of more than 10 lakhs. So there should be a city-based radar system. There should be the vulnerable region like coastal areas, hilly areas, the Himalayas, etc. And entire country should be there. And next point, what we decided that there should be redundancy. We should also consider the older radars. We should bring up the new radars. We should replace them. So all these things are taken into consideration. In addition to that, we decided that to support the entire understanding of the ocean atmospheric system, we should have the augmented upper air observations, that RSL systems. So we have got now 56 RSL systems. We should go for 116 that we decided. So all the decisions were taken by doing a benchmarking, by comparing all the leading countries, and one RSL station at every 180 kilometer grid, and with the installation of 100 wind profiler and microwave radiometers, there will be upper air observations every 120 kilometer grid. So objective is that you have to find out wind, temperature, humidity. These three parameters are very important in 3 dimensions or 4 dimensions, and hence it will help the modeling system. So if you look at automatic weather stations, yes, we have the plan and it is already implemented in collaboration with the Minister of Agriculture, Minister of Panchayat Raj, that every panchayat will have one AWS or ARG. By that way, it will be 131,500 automatic weather stations in the country with the implementation of a scheme called WINDS. So that is a collaborative approach led by Minister of Agriculture and technically led by India Meteorological Department. And of course, there will be high wind speed recorders and other instruments, etc. Drone and UAVs also will be taken into considerations. So this is that winds I was talking about. On the left-hand side, you can just imagine. So what will be the thickness of observations after implementation of wind. At the same time, also, we have to go for public-private participation, and we have to augment our observation systems considering the private observations also. For example, in IMD, now we are utilizing the observations taken by Zomato. So we are providing forecast to Zomato, and we are getting observations from Zomato. So I gave just one example how in the ground grassroots level, IMD is also working with the various stakeholders. So this is just example you can see on the right hand side diagram. IMD, the state government, Zomato, National Hydrology Project. So all are working together to complement the observational systems. Now this is the IoT and the sensor networks requirement. IoT devices and sensor networks to collect real-time environmental data. The sensors provide valuable information. So we are going for IoT. So there is a scope here to work together for deployment of IoT, for improving the quality of IoT, and the collection of the weather data. Satellite technology, yes, we are going for the INSAT 4 series. We have given our input. I think ISRO is gearing up to bring up the INSAT 4 series of satellites. In addition to that, there will be many other initiatives globally with respect to satellites. And being a part of the coordinated group of meteorological satellites group, we are also benefited. We provide our information. We also get information from other satellites in the globe. Apart from geostationary satellites, there will be multiple polar orbiting satellites, LEO satellites, like spectrometers, hyperspectral sensors, etc., which will help further with the geostationary satellites. Now, this is what the radar network will be, and you can find out gradually this number will go. And target is that by 2027 March, it will be 79 radars. So this is the D2 site status. You can see on the right-hand side, this is at 47, ongoing 34, and mission 53, total 126 radars. So if we just look at upper air observations, this is the network after the implementation of 60 new RSL stations. On the right-hand side diagram, you can see. And we have increased the number of ground stations from 6 to 12 from last year. Now, this is the environmental monitoring. Yes, in view of the climate change and the impact of the various environmental parameters, we are increasing our aerosol cloud interaction instruments in dynamic fog chemistry, aerosol LiDAR, sky radiometer, aerosol background carbons also, and ozone network and total corner ozone. So, if you come to modeling, yes, it also needs infrastructure because need is that we have to go for sub-kilometer resolution modeling for regional and location specific forecast. And global model also, we have started with 6 kilometers, but we have to go further. If you look at the plan of ECMWF, we have to go like that also. So for this purpose, we look at there is a huge need of high performance computing system. We have purchased something, we are going to purchase something else. But the collaboration among the agencies also will help, because there are two-way demand now. One, earlier the HPC was required only for physical modeling, but now the apart from CPU, GPU demand is going on, and there is a need for AI modeling. So therefore, now the demand has increased, and accordingly, the collaboration only can help within the country and the region to maximize the SPCs. And this is high resolution modeling I was talking about. You need high resolution modeling to capture very small scale turbulences, for example, icing or precipitation. So that cannot be captured in the global models. Similarly, if you consider the impact of climate change in a particular city, in one part there can be heavy rainfall, other part may not be heavy rainfall. And heavy rainfall frequency is increasing, intensity is increasing. So to detect those, we have to go for, say, urban scale modeling, and to go for higher resolution modeling system with better data assimilation, better physical processing, and parameterization of the various processes. So now, if you look at the AML, I will just little more, I'll talk a little more. It is accelerating the development of digital weather forecasting. So if you take the HPC, even at 5:30, if I take observation, my forecast will generate at 9:30. At least like 4 hours to generate the forecast from physical models utilizing HPC at present what we have. The AML models come out which can provide you forecast in 2 minutes. So for a poor country, for example, or for an island nation, for example, like Maldives, they cannot afford to, or they may not be able to afford to HPC, but they can have a box model of AI which can provide forecast in 2 minutes or say 5 minutes. So that is the state of art which have already come up in the globe. WM has demonstrated that one. Therefore, we are also putting the stress on that we should have a solution which will left behind none. Whether a poor country, the least developed country, developing country, or it is a poor island nation, small island nations, all should be benefited by the technology equally. So these are the data-driven models, and we are taking up there, and extensively applied across various applications globally also. Here also there is a scope. So a roadmap, if you just look at it, is a policy framework. As all of us know that the government has also brought up a policy framework. Established research laboratory, we have come up with the establishment of a virtual lab in IITM, and we have got a group of experts working in a ministry, and there is another group of experts working in IMD, and you have seen the development, and I am sure that it is not simply modeling. AI can be utilized in various processes, as I explained to you, in post-processing, in pre-processing, and also development of sectoral applications and improving the downscaling. So all these things are the part of the roadmap. Now, technology for upgradation of the services, we just look at, for example, aviation services. If I look at for next 5 years, can you imagine that how many numbers of airports will be there in the country? So it will be more than 300. So therefore, we have to gear up towards that with the low-cost sensors, low-cost technology, so that we can cater to the requirement. At the same time, you cannot have so much manpower, you have to go for the automation. So all these things can be held with the help of the physical model plus AML model. Similarly, if you look at the helicopter services, India is becoming a developed country. People can afford the heliport services. Heliport can come up in a large number in the country. So you have to prepare for that. So therefore, heliport weather observing systems, forecasting systems also a huge step forward with the technology. Similarly, sector-specific applications, we take national highways, state highways, railways, waterways, ropeways, power, health, etc. Even for entertainment also. So there will be a huge demand, and therefore the agency has to be geared up to provide the services. An agency like National Meteorological Service cannot do alone. They have to go for collaboration, public-private participation, industry involvement, R&D involvement. So all these things is the need of the hour. Now, if you look at the technology upgradation for the tourism, for example, now people did not have money earlier, so therefore tourism was limited. But now tourism will expand with the improvement in socioeconomic conditions. So at the same time, the vulnerability is increasing. So therefore, tourism will need the meteorological services. We have given tourism, we have the collaboration with the Ministry of Tourism and being provided for our tourist spots. The requirement, if you look at, so someone is coming from UK for visiting Agra. So he might be planning 1 month before, 2 months before. At that time, he will need some kind of seasonal forecast. Then monthly forecast. Then 15 days before, he will go for extended range forecast. Then once he arrives here, he will need a forecast to travel by train or by bus or taxi from Delhi to Agra. So demand will be different. Accordingly, in a flawless manner, in a seamless manner, it should move from the generator to the service holders. Similarly, for the communication distribution network and agromet advisory services, demand is the plot level information should be generated for any type of crop, any stage of the crop. We have come up with a solution that is called CUSAT. In the CUSAT, it is a mobile app solution available in Mosam. The farmer can stand in his crop field and write the name of the crop, the stage of the crop. For example, he is from, say, from Haryana, and there is wheat now. He can write whether wheat is in flowering stage. So he'll simply write or select wheat, flowering stage. Based on these two informations, he will get the forecast for next 7 days, and also he will get the information about what intervention he needs, whether he should go for irrigation, or whether he should go for application of pesticides, or he should go for based on weather-related diseases. That also he can think and decide. So that type of solution is the need of the hour. We have just made a small attempt towards that, and we are moving forward. Now, new emerging service areas, if you just look at this, is the climate service, integrated urban hydrometeorological and climate service. Urban area is increasing. And you will find that if you look at the projection, 40% population will be in urban areas by say 2030 or so. So if that is the case, there will be more vulnerability from urban areas. So we have to gear up towards that. And that is one of the challenges. Here also we are working towards that. One of the success stories is that CDAC, Minister of Earth Sciences, IMD, and the state government and the organizations are preparing the urban services for 5 important cities. Already are providing urban services for major metro cities. 175 cities are being provided special forecast in the country. But at the same time, there are critical hydrological services. The water requirement is increasing. At the same time, per capita water availability is decreasing. So we have to find out a balance. So therefore, the critical hydrological services will help in smooth growth of economy. Similarly, there are sand and dust storm, there are cryospheric monitoring, new customer sectors. All these are the new challenges where we have to provide the information. Internationally, also, you will see that there are various kinds of services, and their integration with the national services and regional services will help further. So with this, I will stop here, and I once again thank organizers, Sama and Professor Tyagi Saab and Samashwar Saab for giving an opportunity to make this presentation and interact with you. Now, if you have any questions, I will be happy to respond. Thank you very much.
Thank you very much, sir, for this wonderful stimulating talk. Actually, the Mission Mawsum program of MOES is aligning well with the WMO Day. This year's WMO Day theme, Observing Today, Protecting Tomorrow. Actually, through Mission Mawsum, we are doing that. Thank you very much, sir. Now, before going for the question and answer session, there is a short photo session. I request Dr. Mohan to prepare for that.
Okay.
I think those who are joined online may requested to switch on their camera. You can also come.
Dear all, please switch on your camera. We will take a screenshot. And Dibba, I think you also can take one. Okay. Be ready. 3, 2, 1, click.
There are 2 screens, right? Take both the screens.
And one more, sir. Yeah. Everyone, please. Yeah. Ready? 1, 2, 3. Click. Thank you. Happy WM Day.
Thank you.
Thank you.
Now I request Dr. Madan Sigdal from CDHM Kathmandu and our ECT member of Sama, Nepal, to moderate the question answer session.
Thank you,
Sir,
Dr.
be
Avilas.
with us. Please be with us for 5-10 minutes for addressing the questions from the audience.
Thank you, Dr. Avilas. Now, it was very insightful presentation from Professor Mohapatra. He addressed various key factors, especially observing today and protecting tomorrow is one of the important key theme of this year's WMO. And he elaborated about the IMD mission Mausam very in depth. So I'd like to request our audience for the question answer session. So if you have any question, you can raise the hand and directly ask to Professor Mohapatra. Or if any you have question, you can write in chat box also for virtual presenters. And on-site presenters, you can directly ask the question to Professor Mohapatra. So let me start from my side. I think Professor Mohapatra has delivered a very important session. And one of the important thing which I found about the transboundary issues also. So in one of the presentation, he talked about the quality, I think, including the sub-basins of Nepal, I think, for the improving of forecasting, right? So
maybe the host can switch off the mics of all other people who are not speaking because there is noise coming up from somewhere. Dr. Mohan, or who is the host now? Dr. Divya, can you
Yeah, I already sir muted. Yeah, I have
mute the mic. Okay.
Yes, sir.
Thank you.
Yeah, I have done. Madanji, could you please ask the question again to DG sir?
One of the important tasks which IMD is going to perform in up to 2026 is written as to issue the QP of in the transboundary river sub-basins for Nepal. So as I am also from Nepal, so what actually IMD wants to do in that area?
Yeah, thank you. Actually, there is no such decision so far that we will issue the quantitative precipitation forecast for the transboundary rivers, the part of the river in other country. But I want to mention that under the severe weather forecast program, where IMD is the regional center, we are providing the forecast of heavy rainfall, very heavy rainfall, extremely heavy rainfall in all the countries expected during the next 5 days on daily basis. And the information goes in terms of the impact-based forecast by providing the color codes and by providing the risk assessment. And this risk is based on the likelihood of occurrence of heavy rain, number one. And number two is the intensity of heavy rainfall. And this is the forecast part. And as far as observation is concerned, the mission MOSAM will certainly help with the augmentation of radar system. The neighboring countries also will be covered by those radars. And hence, the radar image and information will be available in the website. And it will be therefore useful by all the countries in the neighbor. The second point is the satellite. The satellite data are already in the IMD website, and IMD in association to ISRO has developed RAPID. RAPID is a tool where it is an interactive tool. In the GIS platform, you can find out the satellite data. You can have the time series of the reflectivity, or you can have time series of the cloud brightness temperature. You can find out the area where, say, for example, it is more than minus 40 degree, less than minus 40 degrees Celsius. So like that, the convection and its impact in terms of thunderstorms, heavy rainfall, etc. can be. In addition to that, similarly, the lightning network of IMD is capable to detect the lightning in the neighboring regions also. So all these informations are being shared in various platforms, including the open WebGIS, which is available in our website, and also the platform of Severe Weather Forecast Program, then RSMC, Tropical Cyclone website, then South Asia Flash Flood Guidance System, etc.
Okay, thank you very much. Now I will take another question in the chat box. The question by Nagaraju. He asked about the weather forecasting using the quantum computing techniques.
Yeah, quantum computing is just taking off. It is a frontier technology. Already in India also there is a national quantum mission. Already government has taken off. But at present, quantum technology is not utilized. It is still very primitive stage. Let it come off, then it will solve the problems of SPCs. We feel that the quantum technology will sort out all the problems with respect to, because it is a huge capacity in the quantum technology. But at present, it is being led by CDAC for the National Quantum Mission, with the guidance from Principal Scientific Advisor to the Government of India.
Okay, thank you. Now, again, there is a chance to ask the question to Professor Mohapatra. Anyone?
Fine. I think there is no other questions. You can conclude, or I'll conclude.
Sir,
So I once again.
Raju ji raised the hand. Raju Attada.
Hi. Yeah, you can directly ask the question here.
Right. Okay. Thank you so much, sir, for the enlightening and informative talk. I am from ISAR Mohali. We have been working on Himalayan disasters for quite long time. But our understanding is still limited because of the observations, as you rightly mentioned in your talk. But at the same time, you also mentioned that there are a lot of advancements are coming up, especially with Meson Mausam. Quite a good number of foothills Doppler weather radars are coming up. Sir, as an academician, how can we contribute to IMD MOES with the help of these new advancements? Could you please guide us?
Yeah. So as an academician, we always encourage with our potential. The number one is that we are a powerhouse of data. Whatever data, it may be limited data, but we have got data from 1901 in digital format. Number one. Number two is that we have got a graded data set available in, again, the IMD website. One can download freely. The third point is that we also have, apart from ground truth, the satellite data, the radar data, which can be provided freely to academicians, the researchers, the students, who can develop the various types of tools and technology, number one, who can understand the data. So there are various ways and means. Number one is that you can simply verify the model forecast. Then you can help in improving the model. Number two is that you can develop the data-driven modeling systems, statistical tools, or the AML-based tools that can help in improving the system. The fourth one is that if you are taking up any project, in the project also you can collaborate and we can provide our expertise. We've got the scientists working in the field. They can also help and they can work together. The academia and R&D institutes can work with IMD. We have signed many MOUs and providing data to many academic and R&D institutes. The next one is that if you have the students, you can send them for intern. We do not charge, of course, we do not pay. But we provide the data, we provide the expertise, they can do the internship. The next thing that if you need some kind of capacity building in terms of say refresher courses or a short modular course, that also we can provide. So therefore, there is unending roads and ways by which the academia can partner with IMD.
Perfect. Thank you so much, sir.
Thank you.
Yeah, thank you. If anyone has a
I just
query, Professor
I
Das,
just have a small query. Although I thought maybe I would ask sometime in future when I meet you personally. But since Raju Atada asked this question about the instruments over the Himalayas, especially the Doppler radar, I noticed that in the future coverage by the Doppler weather radar, especially over the Himalayas, there are still some red areas over the Western Himalayas as well as over the Eastern Himalayas, Arunachal Pradesh area. So, and also the wind profiles that we are planning, radiometers and wind profiles over the mountain region. There are a lot of gaps in the data. So under the, I don't know whether under the mission Mosam, we shall be covering that completely or still we will be looking to fill up the gaps in the future, even after the mission Mosam. Yeah, that's all.
No, Mission Mosam is a ambitious project which is taking care of entire globe entire India in a holistic manner. So when you come up with Himalayan region, just like we started with the Western Himalayan project, which has been implemented, Northeast Himalayan project has been taken off, where 11 radars are coming up there. We have put off more automated stations, automated engages, but still, if you look at the major challenge, which is the cloudburst type phenomena, that means very highly localized heavy rainfall phenomena. This detection is difficult, and perhaps we will not be able to establish automated stations everywhere. Where there is no population, you cannot afford to. Where there is no road, you cannot afford to. So therefore, remote sensing will help, and radar as a remote sensing tool can help, and we are planning only the density population, because again, the radar outreach is limited when you have got another hill peak in front of the radar. And you cannot establish so many radars because radar is also expensive, and it needs also the other infrastructure like roads, communication. If you do not have the tools to communicate, even if you get information, it becomes difficult. So considering all these, another very ambitious project is being taken off in Western Himalayan region by the Ministry of Home Affairs, and details are being chalked out. The target will be to have end-to-end solution, starting with observations, then modeling, the forecasting, and early warning, reaching the last mile in the village, at least half an hour before there will be a siren or something like that, and people can take action towards that.
Okay.
Thank you.
If there are not any questions, I like to close this question answer session. Is there any question from anyone? Last chance? No. So thank you, Professor Mohapatra, for the clarification about your insightful talk on IMD Mission Mosam. And thank you all the participants who asked the question on this issue. And now I'd like to hand over the session to Dr. Abhilash. Thank you, Mohapatra.
So thank you very much. Thank you very much.
Thank you very much, Dr. Madan Sigdel and Dr. Mohapatra sir, for interacting with our audience. So it is time to wind up. So we are already late by 25 minutes. So I request Dr. Mohan Kumar Das, Joint Secretary of SAMA and Head of Hydroclimate and Ocean Center, Bangladesh, to propose the vote of thanks. Thanks.
Thank you, Abhilash ji. Respected chief guest, Dr. M. Mohapatra, sir, distinguished speakers, Honorable President of SAMA, Air Vice Marshal Retired Professor Dr. Rojit Tyagi, sir, and Secretary of SAMA, Professor Dr. Someshwar, sir, and Program Moderator for Professor Dr. S. Abhilash. Honored colleagues and dear participants, good evening. As we come to close of this World Meteorological Day program, it is my privilege to place on record our sincere thanks to all who have contributed to making this event meaningful and successful. I begin by expressing our deep appreciation to Dr. Mohapatra sir, Director General of India Met Department and Third Vice President of World Meteorological Organization for delivering a thoughtful and forward-looking keynote on observing today, protecting tomorrow, and mission motion. His insights have added great value to today's discussion. I extend my sincere thanks to Air Vice Marshal Professor Dr. Rojit Tyagi, sir, President of SAMA, for his welcome address and continued guidance in strengthening regional cooperation in meteorology. I also thank Professor Dr. Someshwar, sir, Secretary of SAMA, for presenting a clear overview of SAMA's activities and for his role in organizing this program. Our appreciation goes to Professor Celestia Saulo, Secretary General of WMO, for her important message shared through video on this occasion. I would like to acknowledge Ms. Satushka Pramachandra, Senior Meteorologist from Sri Lanka Meteorological Department and ECT member of SAMA, for introducing the chief guest. And my thanks to Dr. Madan Sikdal, CDSM Tribune University, Kathmandu, and ECT member SAMA, Nepal, for conducting the question answer session very interactive way and engaging in effective manners. I express sincere gratitude to Professor Dr. Abhilash, Director of ACARR and CUSAT and ECT member of SAMA, for moderating the program and for his leadership in co-organizing this event. I also acknowledge the collaboration and support of the Advanced Center for Atmospheric Radar Research, Cochin University of Science and Technology, and NCMRWF, the ongoing RADMAP 2026 program, Emerging Radar Meteorology Frontiers in Observation and Prediction, has provided an excellent setting for this commemoration and brought together a wide and engaged audience in person as well as online. I would like to thank all participants joining us from across South Asia and beyond, both through Zoom and live streaming, for your time, interest, and active involvement. Finally, I extend my appreciation to the organizing team and technical support staff for ensuring the smooth conducting of today's program. Thank you all again for your presence and participation. With warm gratitude. Thank you. And also on a small note, we also celebrate the program 28th March on coordination of Hydroclimate Ocean Center, University of Dhaka Department of Meteorology, and SAMA together. Thank you. Thank you, Abhilash.
Yeah, thank you. Thank you very much, Dr. Mohan, for presenting the vote of thanks. I think it is now to close the program. I thank all those who are joined offline from here and online across the country and across the world. So thank you very much.